guys. So today we're going to be talking about solving rational equations. So remember, rational equations are equations that have rational expressions in them. Rational expressions are just polynomials, so they're going to have variables in the bottom for sure, sometimes on the top as well. And we want to go ahead and solve this equation for r, but our variable is all in the denominator, so we're going to see how to do this. Remember, if you're adding, so on this side of the equation, we're adding two rational expressions together. Anytime you're adding two things that are fractions together, you have to have a common denominator, right? So because of that, we're just going to look at this entire equation, and we are going to make sure that the entire thing has a common denominator, okay? So this one's 3 over r, 1 over r squared, and 1 over r. Think of r as r times r, right? So if you look at these other denominators, they have r, but they do not have r times r. So this one we're going to multiply by r over r, and this one we're going to multiply by r over r, okay? So that's going to give me that common denominator that I need to combine things. So now let's just rewrite the problem all together. So I have 3 times r over r squared, because I just multiplied r times r, plus 1 over r squared equals r, because 1 times r is r, over r squared. Now if my denominators are the same all the way across, that means that this problem across the top, I can just look at it and solve it, okay? I guess it's kind of like if I wanted to, I could multiply both sides by r squared, and it would just cancel all the r squareds out. So once those denominators match on the bottom, you don't need them anymore, okay? So now I can just forget about them and just work on the problem across the top. So 3r plus 1 equals r, okay? So now I just solve this as normal for r. Let's subtract 3r from both sides. So 1 equals negative 2r. And then to get r by itself, you'd have to divide by negative 2. So r equals negative 1/2. Okay, so there's my solution. But notice up here in the instructions, it says, remember to check for extraneous solutions. So because there's variables in the denominator, they're on the bottom, that means I may come up with something that would make my denominator equal 0. And if my denominator equals 0, then that's an undefined operation, right? But this is an equation, so we're just looking for which r makes this true. And we just found that negative 1/2 makes it true. But to check for extraneous solutions here, all we have to do is to make sure if I were to plug negative 1/2 into this original equation, that I would not get 0 on the bottom. And since one of these is just 1 over r, at least one of them, I know that dividing 1 by negative 1/2 is not dividing by 0, right? So this one has, basically you're just checking to see if your answer works. If it doesn't work, that means it's going to make your denominator equal 0. So that's all you have to check for. Make sure that when you plug it in, it doesn't make your denominator equal 0. Okay? So let's try another one. Alright, so we have 5b squared, and 5b squared. So these two already match. This one is almost there. It's just missing one of the b's. So on that one, we've got to multiply this first part by b over b. So first step every time is get a common denominator. So 1 times b is b over 5b squared, plus 1 over 5b squared equals 6 over 5b squared. Now that all those denominators match, we can cross them out. So I just have b plus 1 equals 6. Subtract 1 from both sides, and b equals 5. Now if I were to plug 5 into any of these denominators, that's not going to give me 0, right? 5 times b is 25, and then 5 times b squared would just be times it by 5 again. So definitely not 0 on the bottom, so we're fine. Okay? So let's try something else. So on this one, see how I have just a 2 here? I still need a common denominator since there's x's on the bottom here and here, so I got to think of this as 2 over 1. So go ahead and pause this and try this example, and then get an answer, and then come back and check to see how you did, okay? So I got a 3 and an x here, I only have an x here, so I know I'm going to have to multiply this one by 3 over 3. And this one doesn't have a 3 or an x, so I'm going to need to multiply this one by 3x over 3x. Okay, so that gives me 3 times 2 is 6x over 3x, plus 2 times 3 is 6 over 3x, equals 1 over 3x. So now that those are the same, I can cross them off, and I'm just looking at this problem across the top. 6x plus 6 equals 1. Subtract 6 from both sides, and 6x equals negative 5. If I divide by 6, x equals negative 5/6. If I plug that in here, 3 times negative 5/6 will not be 0, so my solution is fine. Okay, so let's try something else. Alright, so here I have x squared, 6x squared, and x. Again, if you want to try it first and then come back and watch the video, or unpause the video, that might be a good idea. I have a 6 and I have an x squared, so that's 6 times x times x. So I've got 1x here, which means I'm going to have to multiply this one by 6x over 6x. This one is missing the 6. Remember, if I multiply this top by 6, I've got to multiply it by everything there. So put parentheses around there. So now I've got 6x squared all the way across the bottom, so I can just cancel those out. And now I'm going to go ahead and do the problem across the top. So 6x minus 36 plus x minus 4 equals 2 times 6x, which would be 12x. So now just simplify, combine like terms, get x all by itself. 6x plus 1x is 7x. Negative 36 minus 4 is negative 40 equals 12x. Let's go ahead and subtract 7x from both sides here. So that would give me negative 40 equals 5x, and then just divide by 5. So negative 8 equals x. Okay. Alright, so once you know what x is, make sure that if you were to plug it back into the original, that you won't get 0 in the denominator, which we won't. So we're good there. Okay. So let's skip ahead here. We're going to skip a few and try something else that looks a little different now. Okay, so look at this one. So remember from our work with rational expressions, if I have a plus or minus here, I've got to think of these as one number, right? So anything that has a plus or minus in the middle, just go ahead and put parentheses around it, okay, to remind you of that. This is one number that can't be, I can't cancel out half of it. In order to get a common denominator, I would have to actually multiply by the whole thing. I've got this 1 here, which we'll think of as 1 over 1. So these two actually already have a common denominator of n plus 2. So we just need to give this one right here the same common denominator. So just multiply by n plus 2 over n plus 2. Okay. So now that all of these have an n plus 2 on the bottom, I just cross them out. So I've got what's left across the top. So I've got 4n minus 20. And then I have 1 times n plus 2, which is just plus n plus 2. Now notice here that I'm minusing this next term, and this next term has more than one term also. So I've got to kind of distribute that negative, make sure I subtract both of these. So that's going to become minus n and then plus 5. So now I can just simplify. Oops, I forgot my equal sign. Where does it belong? So we had 4n minus 20 equals 1 times n, so this should be equals here. So I'm going to go ahead and combine like terms here. N minus n, oh, that's just going to go to 0. 2 plus 5 is 7. So I have 4n minus 20 equals 7. So add 20 to both sides. And 4n equals 27. So if I divide by 4, n equals 27 over 4. Okay. Now 27 over 4, if I add 2 to it, does not make a 0, right? If I would have gotten a negative 2 here for my solution, I'd be concerned because that would make my denominator 0. So I would have to say no solution. But because this one won't make my denominator equal 0, that's a fine solution. Okay. So we're just going to try one more. Again, I'm going to recommend that you pause the video and give it a try first. and then come back and we'll do it together. Okay. So this is very similar to the previous example. I have m plus 3 and m plus 3, but 5 over 1 needs that same denominator, so I'm going to multiply by m plus 3 over m plus 3. And then once those denominators all match like I just made them, now I can cross them out and just work on the problem across the top. So I have 1 equals 5 times n, right? I'm going to have 5 times m and 5 times 3. So 5m plus 15, and then I've got another plus 3 here. So that gives me 1 equals 5m plus 18. And now just solve for m. So subtract 18 from both sides. So negative 17 equals 5m, and divide by 5. Okay, so m is negative 17 fifths. Negative 17 fifths plus 3 is not 0, so that's a good solution. All right, guys. Good luck trying this. If you need help, please don't hesitate to contact me, and I will see you later.